Task number one of the pull toy project is vocabulary. You know that you'll be working through a new design notebook, and so we want to make sure that you have reviewed it, that you've taken some time to look through to see what exactly is going to be done. And then you're going to complete vocabulary. And so the vocabulary words that you are going to look up and explore are mechanism, chassis, transfer, configuration, and fabricate. So as always, we want to make sure we're using our own words for the definitions. Do not just copy and paste. And then in the Frayer models, we want to find an image, examples, and non-examples for each term as well. As we start thinking about our pull toy, we want to start thinking about this essential question: what would I like the output of my toy to be? So as I pull the toy along the ground, which you'll learn about in just a little bit, as I pull the toy along the ground, like you see the ducks up here in the corner, as I pull this string and the wheels, and this wheel's along the ground, what do I want to have happen? What do I want the output to be? And so in this pull toy, the little paddles spin and move, and so that's going to be kind of an example of what you are going to do. So that should be the question that you are trying to answer as you go through this today. So at this point, let's pause the video and open up your design notebook. All right, we've got our design notebook open. You should put your name up here at the top in the heading, so we know that it's yours. Then you see task number one. So task number one is, again, to work with the vocabulary, the Frayer model, but then you're also going to read through some project criteria and constraints and have an opportunity to ask some questions before you begin. Part of inquiring and analyzing is asking those questions and making sure that you really understand something before you get started with it. So that's going to be the task today. So let's click on the bookmark over here and take you down to the start of task number one. You see again our essential question here: what do I want the output of my toy to be? At some point you'll want to answer that as you start thinking about how you want your toy to work. Here's some just general directions about the Frayer model, the vocabulary activities that you're going to do. And then you see the first term, mechanism. So again, we want definition, image, examples, and non-examples. So the easiest way for this is just to go to Google. First word was mechanism. You can type this in, mechanism definition. Got to spell it right. You type in mechanism definition, you get a couple definitions right here. Make sure you're thinking of the context. So our context is robotics and computers and toys and gears, and those are the things that we've been learning about lately. And so find a definition that has to do with that. When you find one, for instance this first one right here, we don't want to just copy and paste, but we want to put that into our own words. So a system of parts working together in a machine, a piece of machinery. So a system of parts working together in a machine. I understand that, so I just need to make sure that I type that into the definition box here in my design notebook. When you're ready for an image, it's just easy. Click on images at the top. You get images. I probably want to take out the definition word here. Just say mechanism, because then it's going to give me a lot better pictures in terms of some different mechanisms. All right. Then you can go back to, again, examples and non-examples. If you're having trouble, you can look up the word synonyms, words that mean the same, or if you go back here again into Google, mechanism, examples, you might be able to type that in and see. I'm still on the images, so I can click all, see what some examples are, and here it gives you some examples right here. What are 6 mechanisms, examples of mechanisms? So there's a lot of different ways that you can find that. All right, so you're going to do that as you go back to your design notebook now for mechanism. This next word is pronounced chassis. Okay, not chassis, but chassis. Transfer, and then the two should define words are configuration and fabricate. Then you get down to the product criteria and constraints, and so we want to read through kind of this information. If you want to read through this on your own right now, pause this video. Otherwise, I'm going to read through it to you, and you can just follow along with me. Introduction. So I'm just going to read this paragraph. A pull toy is pulled along the ground and a movement is produced, such as a head nodding, a tail wagging, or a figure bobbing up and down. The pull toys use mechanisms to transfer energy from the wheels to the characters that define them. So the equipment that you're going to be using for this, design notebook, pencil, paper, and then the VEX parts. So here's your procedure. With your knowledge of mechanisms, you're going to use the design process to design and fabricate a series of mechanisms that will meet the following criteria. The mechanisms are to be built entirely from VEX parts provided in the lab. The pull toy is to be built on a small 4-wheel chassis capable of being pulled across the floor. The movement of the wheels will make the toy move. A gear mechanism attached to the wheels will make another part of the toy move. You must use more than one type of gear train and/or mechanism to make your pull toy work. And an illustration should be added to the mechanism so as to simulate the toy. All right, so think back to the mechanisms in the last unit that you built and explored. You're going to use those to create your toy, and you do need to use more than one of those. Okay, you should also document how you use the design process in this design notebook. Complete your design process chart in your notebook each day, and that's just each task here. Add activities, notes, thoughts to each row of the chart where they best fit. You're going to be graded on each criterion of your design class, so inquiring and analyzing, developing ideas, creating the solution, and evaluating. And inquiring and analyzing and developing ideas need to be completed before you create your solution, before you begin construction. So make sure the things that are labeled, you just scroll down here like this right here on task 2, inquiring and analyzing, make sure that that gets done before you start building. Based on experience, students that just start building right away, it takes them longer, it's more difficult, more challenging, and normally those students don't get done because they have not asked questions, they've not done their research, and they don't have a plan for building. So make sure that you're doing those things as you inquire, analyze, and develop your ideas. So at this point now, I want you to think through this project. Are there questions that you need answered? These are questions you're just going to make a list of things that you need to reach out to your teacher and get answered. So I had this one question right here. It talks about an illustration should be added to the mechanism. How are you going to add an illustration to the VEX robotics parts when you build? That would be my question. How do I add an illustration? That's a question that I need an answer to before I move on with this. And that's a good question that your teacher should be able to answer for you. So go ahead, pause the video, and write down, list any questions that you maybe have. Now that you have your list of questions, the last thing for task number 1 is a summary. What was something you learned? Probably learned a bunch about what this project is and what you're supposed to do. If not, that's probably something you need to ask your teacher about. And then what was some example of success that you experienced with task number 1, whether it's the vocabulary, reading through that background information, or asking these questions. All right, then you see the end of task number 1, and you are done. Please reach out to your teachers with any of those questions that you maybe have. Good luck.